Hello students, welcome to Shree Agarwal Academy. I, Ratan Agarwal, welcome you to today's session. In today's video, we are going to talk about factorization, identities regarding factorization. So, they are very important because they can help us to factorize complex expressions in very easy ways. So, let us learn today factorization. Before I take you to factorization's identities like a square minus b square, etc., etc., let us first know what is the meaning of factorization. 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 The word factorization means a process in which a given number or a given expression is divided into smaller parts, broken up into smaller parts, such that the product of all those parts is the original number or original expression. Let us take an example. For example, if they give us x square, it's a single term and they say factorize. So, I would write this x square as x into x. So, the factors of x square are x and x. If they give us 36x square, I would write this as 6 into 6x into x. And I can write this as 2 into 3 into 2 into 3 into x into x. I may write this as 2's square into 3's square into x square. So, there are 6 factors of 36x square, which are 2, 2, 3, 3, x, x. If you see, these numbers are prime numbers, they cannot be further factorized, hence these are the prime factors of 36x square. I hope you are understanding. Factorization is the process of breaking up the given number or given expression into certain numbers whose products are the original number. Let us take another example. Now, here we had taken a single term, a monomial, here also monomial. Now, let us take a binomial. I am taking 3a square plus 12ab square. Yes. Now, here there are two terms, first term, second term. It is a binomial. If you want to factorize, the process is like this. Of course, when you go to like higher levels, you need not do all these steps, but because we are learning it, I am explaining it to you all the steps. So, I will write first of all the prime factors of this term 3a square, 3 into a plus I think this is 3, 2's are 6, 2's are 12 into a into b into b. So, I factorize this 12ab square into prime factors. I factorize 3a square into prime factors. Now, whatever are the common factors, let us underline them. And now, let us take these common factors outside. So, 3 is common, taken out, a is common, taken out. It means in these two terms, 3a is common, it is a common factor, we have taken it out. Let us go inside and see what remains. From these three terms, 3a gone, only a remained, plus 3 gone, a gone, 2 2's are 4, b square. So, the factorization of 3a square plus 12ab square is 3a is the first factor and the second factor is a plus 4b square. So, if you multiply these two terms, you will get these two terms. So this is how factorization of binomials can be done. Factorization of trinomials can also be done. There are different methods, like first one is using identities. Before that we have prime factorization method. Second is using identities. Third method is splitting the middle term. Fourth method is completing the square, and fifth method is formula method. It is also called as alpha beta method. These methods we will learn in some other videos, but today we are going to focus on factorizations, and we are going to study some identities regarding factorization. Okay sir, this is factorization. But now sir, if they give us an expression like this, a square minus b square. So what are the factors of a square minus b square? The factors of a square minus b square are a plus b, a minus b. Now why are these two factors of this expression? Because if you multiply them, a is a square. I will show you the justification. If you multiply this, a is a square minus ab plus ba minus b square. Now you know ba and ab are equal, so these two with positive and negative signs will cancel, and what will remain is a square minus b square, means the simplification of these two brackets, the multiplication of these two brackets is going to give us the LHS. So the factorization of a square minus b square is nothing but a plus b, a minus b. Okay, I think you have understood. If you have understood a square minus b square, whatever they give instead of a square minus b square or a and b, we can write it very easily. Like what are the factors of x square minus y square? They will be first term plus second term, first term minus second term. Now we will take some more examples. Suppose they say 4x square minus 9y square. Now you know 4 is someone's square, 3 is someone's square, they are perfect squares. So this 4x square I would write like this, 9y square I would write like this. I am sorry, this has to be 3y. So now this is in the format of a square minus b square. The factors would surely be a plus b and a minus b. Yeah, correct. Let us take another example, third example. Suppose this was a perfect square and we could do it easily. But if they give you like this, 5a square minus p square. Now 5 is not a perfect square, but it is someone's square. Whose square is 5? 5 is the square of root 5. So I would write this expression as root 5a bracket square minus p bracket square. So we wrote it in the format of a square minus b square, and therefore now the factors will be first term plus second term into first term minus second term. There will be many such examples wherein we can write the factors very easily if we follow this pattern, if we follow this formula. I will take one more example for your understanding, because then things will become clearer. Suppose I say a square upon 36 minus b square upon 100. Well, fractions have come. If you see, our a is a upon 6, our b is b upon 10. The original terms you should be able to identify. And so the factors will be a upon 6 plus b upon 10 and a upon 6 minus b upon 10. I hope you are understanding. So this is how the factors of a square minus b square can be understood, and we can factorize. Let us go to slightly a level ahead of this. Means now, instead of taking a cubic factorization, I am taking a biquadratic factorization. What? Suppose they want us to find the factors of a raised to 4 minus b raised to 4. A raised to 4 minus b raised to 4. Now this can be simplified by using laws of indices. What are the laws of indices? You know. So I am going to use here the law x raised to m raised to n is equal to x raised to m into n. So this a raised to 4 can be written as a square's square, and b raised to 4 can be written as b square's square. Now you can directly write, or you can make a substitution step here. I will say substitute or put a square is equal to x and b square is equal to y. So here what will happen? A square is x, its square. B square is y, its square. So now we got it in the form of x square minus y square. And this x square minus y square can be factorized by this formula. So we will write x plus y, x minus y. Now we will say resubstitute. Resubstitute what? X and y. So this will be, instead of x we are going to write a square. Instead of y we are going to write b square. Instead of x we are going to write a square. Instead of y we are going to write b square. No more factorization of this. So we go ahead with a square plus b square. Factorization of this, we know, sir, this is a standard factorization. A plus b into a minus b. So finally, the factors of a raised to 4 minus b raised to 4 are a square plus b square, a plus b, a minus b. Of course, factors of a square plus b square can also be done, but in this stage, in this level, factorizing till this is enough for us. I hope you understood the factorization of a square minus b square, how it is to be used, how factors are to be found, even if there are fractions, even if there are rational or irrational numbers, and I showed you the factorization of a biquadratic expression. In our next video, we are going to learn about cubic factorizations, that is a cube plus b cube factors, factors of a cube minus b cube, and so on. I have all this uploaded on my YouTube channel called Shree Agarwal Academy. I am available on Instagram, Facebook. Do subscribe so that you will learn a lot of more new things there. You will clarify your concepts and maths can become your friend. Thank you.